to part 2 of this mini-series on equation of a straight line. In the first tutorial we did lots of examples and we motivated that sort of workhorse equation that I obviously am quite keen on, which is y equals mx plus c. And in this tutorial we're going to be deriving particular examples of that equation given sort of limited information, and that's a very typical problem that students will be asked to solve at this level of mathematics. So let me just write this majestic equation down at the top here, y equals mx plus c, and just to remind you, the m is the slope of the line and the value c is the value of y where the line, the straight line, cuts through the y-axis. Let's just, before we do these examples, just say a little bit more about the slope. Imagine I have some straight line, okay? Now, if we wanted to think a bit more precisely about what is the slope, we can sort of imagine drawing a line that comes directly down and then drawing a line that just goes across and making actually a right angle triangle here. And the way we define the slope is to say that the slope is this value divided by this value, okay? I'm actually going to use a symbol here that you might only see in a slightly more advanced maths class, but it's a very useful symbol, so let's just use it. Delta y, let's call it delta y, and let's call this delta x. In maths, this symbol, I know it looks like a triangle, it's actually the Greek letter delta, and it's the capital of that. That's used to mean the difference in, and it saves us having to write the difference in. So the slope is the difference in y divided by the difference in x. So that's how we define the slope, okay? Let's now use this piece of knowledge to do the following examples, which are very common exam problems. Let's imagine that you are given two pairs of coordinates. Let's say that one of them is at 2, 3, so that's going to be 2, 3, so something like that maybe. And the other one is at 4, 7, so 4 would be roughly here and 7. I'm not doing this very precisely, this is really just a sketch to motivate the problem. So this is the 2 points. Now we can already sort of see what that straight line is going to be, because if you have 2 points on this xy plane, then it uniquely defines a straight line. There's only one straight line can be drawn that goes through both points. But our job is to derive the equation for that straight line. And we're going to do this in 2 steps. So just to say that's 2, 3, and this is 4, 7. We're going to first of all find the slope, and we're going to use this idea that the slope is the difference in y divided by the difference in x. And you can see that the difference in y is the y value of this point take away the y value of this point. So it will be 7 take away 3. And then the difference in x will be here, it's the x value of this point take away the x value of this point. It would be 4 take away 2, which is equal to 4 divided by 2, which is equal to 2. So the slope of the line that passes through both these points is 2. It doesn't matter which way round you sort of take these points. I've done 7 minus 3 divided by 4 minus 2. You could equally well, it would be a little bit perverse maybe from this diagram, but you could do 3 take away 7 divided by 2 take away 4, and you would get negative 4 over negative 2, which is still equal to +2. I just have with these problems, I always calculate the slope by taking the values of this point from the values, take away the values of this point. And then in step 2, we need to choose one of the points. I always choose the leftmost point. So for step 2, we're going to sort of like prepare the equation of a straight line. So we're writing the variable y. We're taking away from that the y coordinate of this point. You could choose that one. I always choose the left point for the second step. So y, take away the y value of this point, which is 3. And we write that equal to the slope, which in this case is 2, all multiplied by x, take away with the same point its x value, which is 2. Okay. So this is an example of an equation that you sometimes see, which is y minus b equals m x minus a. And that's an alternative equation of a straight line given a pair of coordinates a comma b and a slope m. So I'm using the pair of coordinates 2 comma 3, and I have a slope of m. And so you see that's how one has this equation here. I'm not sure you need to memorize this equation. To be honest, I think you can memorize the algorithm, which is that you choose a point, say the left point, you take y minus the y value of that point equals the slope times x minus the x value of that same point. Now we just have to tidy this up. So we have that y take away 3 is 2x take away 4, and so adding 3 to both sides, I have that y equals 2x minus 4 plus 3. I know some students are a bit unconfident about moving things across the equal sign, and I will do another tutorial on that topic in this series. You can just think of it as adding 3 to each side, and then that negative 3 gets cancelled out, and we have plus 3 on this side. So finally then, just tidying up, we have that y equals 2x, and then minus 4 plus 3 is negative 1. And that would be the equation of the line that passes through these 2 points. That should be clear. If we draw a line through them, we see that it has quite a steep slope, and it passes through a value of y which is negative. So that's consistent with the equation we've found. Let's do it quickly, another example. So I want to choose for my points here negative 3 plus 3. I'm choosing some negative values now because you have to be very, very careful with minus signs when you do this type of thing if you have negative values around. And the other point is 5, negative 1, which would be about here. And again, the precise values don't matter in terms of the sketch. It's just trying to get an idea where the points are. Okay, so those are the 2 points we've been given, and the question is, find the equation of a straight line that goes through both those points. Step 1, find the slope. And it's going to be the difference in y divided by the difference in x. I just always take the values of the right point and take away the values of the left point. So I have negative 1 for y, take away 3. Divided by the x values, I have 5, take away, and be very careful here, a negative number, so 5 take away negative 3. And that gives me negative 4 on top, and it gives me 5 take away negative 3 is 5 plus 3 is 8 on the bottom. So I have a slope of negative 0.5. And you can do sort of a sense check at this stage. That looks about right. We're going to have a negative slope for the line that passes through these points, and it's probably going to be quite shallow, so that looks reasonable. Now step 2, I choose the left point. I have y take away the y value of this point, which is 3, equals the slope, negative a half, times x take away the x value of this point. And look, it's negative. I have to be very careful. So I'm going to put that negative number in brackets to make sure I remember it's negative. And then I'm going to do a little tidying up here. I have x take away negative 3, and that's x plus 3. And then I can multiply this out. So this gives me minus a half times x, and then take away 3 halves. So finally I'm going to add 3 to both sides, and then I'll have that y equals negative a half x, and then take away 3 halves, and then plus 3. So I'm taking this negative 3 across, which is equivalent to adding 3 to both sides. So finally then I have y equals negative a half x plus 3 halves, because 3 take away 3 halves is 3 halves. And that's the answer. That's the equation for this particular straight line, which I will try to sketch. And it looks reasonable, right? You know, it's cutting the y-axis at 3 halves, has a slope which is clearly negative and quite shallow, so that looks very reasonable. One thing that you can do once you've found the equation of a straight line, and I really recommend you do this, you can put both values of x in for your 2 coordinates and check you get the right value of y, and you absolutely should, and if you don't, there's definitely an error. So for this first example, if I set x equal to 2 in my equation, I get y equals 2 times 2, take away 1, which is 3, which is the right y value. And if I set x equal to 4, which is the other pair of coordinates, I get y is 2 times 4, take away 1, which is 8, take away 1 is 7, which is correct. For this example, if I set x equal to 5, I have y is negative a half times 5, which is negative 5 halves plus 3 halves. Negative 5 halves plus 3 halves is negative 1. That's the correct y value. And lastly, if I take x equal to negative 3, I have y is negative a half times negative 3 plus 3 halves. And negative a half times negative 3 is 3 halves, and then I have 3 halves plus 3 halves is 3, which is the correct y value. So all is well. So those are 2 examples. I hope you found those helpful in how to derive the equation of a straight line in this sort of standard canonical form from being given 2 pairs of coordinates. It's a 2-step process. Step 1, use this idea to find the slope. Step 2, take one of the pairs of coordinates. I always take the left pair and take y minus the y value of that point equals the slope times x, take away the x value of that point, effectively using this alternative equation of a straight line, which some people like to memorize. So quickly, to finish this tutorial, I just want to mention an alternative form of the equation of a straight line. So I'm just going to make a little box here. This is a separate topic. You sometimes see sort of alternative form. You sometimes see equation of a straight line written in a different way, and it can be very confusing. Alternative form of a straight line equation. And it would look something like this. It would be something times x, and then added or subtracted something times y, and then maybe a number like this. And someone would say, that's the equation of a straight line. What's the slope, for example? That might be the question. And this really is about equation rearranging, and I will give a tutorial on how to rearrange equations. It's such an important skill in maths. But essentially we want to turn this into this. In other words, we want to isolate y. So the first thing to do would be to take these 2 things that are not y over to the other side. That would just leave me with 3y on the left-hand side. So I'm effectively subtracting 2x from both sides of the equation, and I'm adding 1 to both sides of the equation. And to isolate y, I want to get rid of this factor, so I'm going to divide by 3. So 3y divided by 3 is y. I'm going to divide by 3 on each term on the right hand side, and you see I'll just get this. And so this funny equation, as it were, is completely equivalent to our good old friend y equals mx plus c, and we see this opaque equation, when written transparently, says it's a straight line with a slope of negative 2/3 and it cuts the y-axis at 1/3. Let's just do another example. Let's say we had negative x take away 2y equals 4. You might have something like that. So in this case, I would probably be inclined to just, again, take x over to the other side, and I would have negative 2y is x plus 4. So I'm effectively adding x to both sides. And then I want to isolate y. I'm going to divide by this factor of negative 2. So y will be x divided by negative 2 plus 4 divided by negative 2. If I just shift that up a tiny bit there, we'll see then that we have y is, now dividing by negative 2 is like multiplying by negative 1/2. So y is negative 1/2 x take away 2. And that would be the effective equation of that straight line in our good old y equals mx plus c form. I'm just going to check I've done that right, actually, because when you're teaching, you're not always as focused on the actual maths as you would normally be, but that looks absolutely fine. Yep, I think that's fine. So that's the topic of the equation of a straight line. I hope you have found that helpful. I've done it a little bit swiftly, but I think lots of practice is the key. So you can just practice particularly this skill of just write down 2 pairs of coordinates, go through these steps and derive the equation of a straight line. This will be very useful in much of the maths that we do in the future. So very good, and I'll see you for the next topic next time.